Okay, so we've got to find or estimate the gradient. So what I'm going to do is I'm going to draw a red line onto my graph, and I'm going to use it to create a triangle. So you want to try and make a nice long line so that it's easy to stick the points in. You can actually see, you can read off the scale quite easily. So I've chosen a triangle like that because I can read off the y height, which is going to be 3.6, and I can see it goes up to 6, and it's a negative gradient, so negative. So minus 3.6 divided by 6 is the rise divided by the run, isn't it? And that's going to give me, well, you can probably guess that in your head, but let's just check on the calculator, why not? So if I do that, I find the gradient is minus 0.6. Okay, make sure you got the negative sign in there. Right, so now we've got that done, I can just write a little sentence for the exam to show asked this question. The gradient is approximately minus 0.6, and I'm sure they'll give us some leeway above and below in the mark scheme. Right, now we're going to look at finding the equation of that straight line. Now you could probably just read, now that you know the gradient, you could probably just read it off the graph and the line you've drawn, but I'm going to work it out algebraically, even though this is a geometry question. And so I'm going to find the point P, and I know that is 2 and 2.4 from looking at the graph. I know the gradient M is minus 0.6. I want to put a line through that point P with a gradient of minus 0.6. So the way I'm going to go about this is I'm going to use the formula, which is really an A-level formula, but I find it it gives me what I want very quickly. I'm going to use y take away the y coordinate is equal to the gradient times by x take away the x coordinate. So that's y1, x1, that's the point P, and m of course is the gradient I found. So y take away my y coordinate, which is 2.4, is equal to minus 0.6 times by x take away my x coordinate, which is 2. If I tidy that up, I've got my answer. So I'll take my time over this. Now of course I realise that you could have just read this off the graph, you've got the y-intercept, but then, you know, how accurate is my diagram? I don't know. So I prefer to do this. So you can see, yes, we could have read it off the graph, but now we know for sure. Okay, so now what the next part is, we've got to find, on this curvy graph, we've got a line where it goes through the graph in the same place, two solutions. So I've drawn the only two lines I could see where it goes to the graph twice. Do you see if I put the line anywhere else, that red line anywhere else, it's going to have three solutions. It'll go through the curve in three different places, but I only want two. So it looks to me that f of 0 equals 3, as does f of 12 equals 3. So one solution is 3, and the other solution is when you put in f of minus 4 and f of 8, and they both equaled minus 1. So I think the answers are 3 and minus 1. Okay, so let's have a look at the mark scheme then. You might want to pause here, it's quite long, isn't it? Do have a good read though. Okay, and of course the mark scheme. And I'm interested in minus 0.6, yeah, so let me have that. We've got the equation right, and 3 and minus 1. Good, so I'm feeling pretty happy about that.